Welcome to Hartman Math. This is lesson 5.4, graphs of exponential functions. So we have a new type of function, f of x equals 2. So a number there, that's called the base, being raised to a power of x. So our independent variable x is now the exponent. In the past, x has been the base. We've raised it to the second power, parabolas, x to the third power. It's a little different. So this time the x is the, or at least part of the exponent. Right now it is the exponent. 2 is the base. What has to be true for exponential functions is that our base has to be positive and it cannot be 1. So those two conditions have to be true. And 2 fits that condition. It is positive and it's not 1. So our base could be 2, 3, 2.5, 10, 1/2. Although if it was 1/2, it wouldn't be a growth function. So we're going to stick really with bases that are greater than 1. So we got a new type of graph. So we're going to take a look and do a table of values. We've got some negatives and some positives. We'll see if that works out here as we do our function value. So 2 to the power of -2. So that takes us back to exponent properties before. 2 to the -2 means do a level change, send it to the bottom, 1 over 2 squared. 2 squared is 4, so it's 1/4. So we're going to plot that point left to up just a little bit, 1/4 of the way from 0 to 1. All right, let's try -1. 2 to the -1, again a negative exponent, means a level change. So it means the reciprocal, 1 over 2 to the first power. So 1 over 2, it's a half. So left 1, up a half. And 0, again exponent properties, 2 to the power of 0 is not 0. If you remember, any real number, aside from 0, raised to the power of 0 is always 1. That's the 0 exponent property. So 0, 1 is the point there. And then 1, 2 to the first power is 2, so 1, 2. And then 2 to the second power is 4, so we got a point at 2, 4. So we can see what kind of the shape is looking like here. We can see it's passing through here. It's going to come down, and as we come down, it keeps getting closer and closer and closer. What's it getting closer to? Keeps getting closer to the x-axis. Every time we go one step further, it gets basically half as close, twice as close, twice as close. So it keeps getting shorter and shorter, but it never is actually going to touch it. It'll never actually get there. So because we have a curve that keeps approaching, getting closer and closer, the farther we move away to this line, we call that line, in this case the x-axis, an asymptote, a little vocabulary word there. An asymptote is a line that our graph, our curve, approaches, but does not touch. When we say approaches, it means it keeps getting closer. The farther you go away, it's going to get closer. It's not going to behave like this. It's not going to go away. It keeps getting closer and closer and closer and closer without touching. So that's what our graph looks like. You might notice these two are different. Those are going to be our key points. Key points for our graph are going to be plug in a 0. You get 1 because of the 0 exponent property. So 0, 1 will be a key point on our parent function. And then 1, now this one in particular, it's going to be 1, 2 because the base is 2. But the base might be 7. In which case we would plug in a 1 and say 7 to the first power is 7. So it would be 1, 7. So really right here it's 0, 1, and then 1, base. This base is 2, so we've got a point at 1, 2. Like I said, if that was a 7, we'd have this point be up here, and it'd just go up a lot faster. So you might want to think of it this way in terms of shape. If we can get those 2 points, use the asymptote that we're getting very close to. Kind of looks like an exponential growth function. It's kind of like an airplane taking off. And it only bends in one direction. So it's not going to go this way. It's just going to bend in one direction. Let's look at some of the key characteristics of our function. We plugged in some negatives, we plugged in some positives. This arrow is going to the right forever. This arrow is going to the left forever. And that is why the domain goes from negative infinity to positive infinity. The range is a little trickier. Okay? How high does it go here? How low does it go? Yeah, it doesn't go down forever. It keeps getting lower and lower and lower. So it's getting very close to 0, but it never touches 0. So we can't use a bracket because it never gets to 0, but it's just above 0, which is why we use a parenthesis for the range, parentheses 0, infinity, to say it's everything above 0. All right, where is our function increasing? It's always going up, so it's increasing over the entire domain. Well, if it's always increasing, when is it decreasing? It's not going to be decreasing ever. The equation of the asymptote, it's a horizontal line, so y equals 0. The end behavior, as x approaches positive infinity, as we go right, we are going to positive infinity. As it goes left, we are getting, what are we getting? We're getting close to something. It's approaching, but not touching, 0. Got lower, here it's a half, fourth, an eighth, 16th, keeps getting lower. It's getting very close to 0. Example number 1, draw the graph of the parent function for g of x. We're going to draw that dashed or dotted. And then the graph of g of x, that's going to be our final graph, solid. Make sure we have 2 key points on each one. So we really just cover this up and say g of x is 4 to the power of x. We need 2 key points. Let's plug in a 0. 4 to the power of 0 is the 0 exponent property. That's 1, so we've got a point at 0, 1. Then we plug in a 1, 4 to the power of 1. We're not considering this, we're just talking about the parent function. F of x is 4 to the x. So plug in a 1, 4 to the first power is 4. So 1, because we plugged in a 1, comma 4, that was our answer, 1, 4. And fitting through these 2 points, getting close to and not touching the x-axis. So we can't go like this because you can't touch the x-axis. It's got to be like an airplane taking off. And we're going to draw this one dotted. Like an airplane taking off. Gets close to but does not touch the x-axis. Alright, so we've taken care of that. Now we can get to here. Well, we have a transformation. We've got a -3. What is this doing? That's the k. So it's shifting down 3. So we're going to take our key points, down 3. Down 3. And the asymptote as well, which was the x-axis, must be moved down 3. So we're going to redraw it. Horizontal line, down 3. It's not really part of the graph, it just helps us along. So we're going to draw that one dotted as well. So there's our asymptote. So here's our new runway for our airplane taking off. Going through these 2 points. Solid graph. we go. It cannot go straight up the page. The domain is negative infinity to positive infinity. It's got to keep moving to right. It cannot bend in the other direction. So be careful. All right, what's the equation of the new asymptote? Y equals -3. What is the range? What are all of our y coordinates? They are all above -3. So we go from -3 to infinity. Once again, parentheses, because it doesn't touch the asymptote. There are no points on -3. It just got really close. The y-intercept, oh, we can see it. It's right there. 0, -2. Now, what if you couldn't see it? How do we find a y-intercept? Plug in 0. Let's give it a try and see if it actually comes out. 4 to the power of 0 is 1. Subtract 3, you get -2. All right. As x approaches -infinity, as we go left on the graph, we're getting very close to what y value? -3. Interesting. Oops, that should be -3. My error. See how asymptote and range and one of the n behaviors all connected. That takes care of example 1. Example number 2. G of x equals 4 to the power of x plus 2 plus 1. Draw the graph of the parent function. The parent function stops at the x, so we're just doing 4 to the power of x. That's our parent function. That's the same one we just did on the last one. So 4 to the power of 0, we plug in a 0, is 1, 0, 1. And then 4 to the power of 1 is 4. So we plugged in a 1. We got 4, 1, 4. It gets very close to the x-axis that all parent functions do for exponential growth functions. So airplane taking off, it's done. This one takes off, goes steeper. Must be a military airplane. All right, so now we've got to do some transformations. So we've got stuff going on here and here. So this is with the x. Which way is that going to move? X is left, right, so this is going to move left, right. And like we've seen before, usually in parentheses, but this time just with the x, we don't need the parentheses, think opposite. So we're going to go left 2, and then this is our k, that was our h, this is our k, up 1. So that's how we're going to move our points. Left 2, up 1, left 2, up 1. Asymptote is also going to move left 2, but that's not really going to change anything because it's a horizontal line that goes forever and ever left and right, so going left to right doesn't change anything. Left 2, up 1, well the up 1 definitely does. We'll redraw it up 1. Must redraw your asymptote if we have a k, if there's any up-down shift. All right, we got our points. Here's our new runway. Okay, don't crash through the runway. Get close to, but do not touch. There's our graph. Asymptote, horizontal, y equals 1. Range, everything is above 1. The y-intercept, oh, we don't see it. It's not touching here, but it's going to because our domain is from -infinity to positive infinity, so we'll get to 0 at some point. Where is it going to happen, though? We don't see it on the graph. Well, let's plug in a 0. G of 0 equals 4 times 0 plus 2, so 4 to the second power is 16. Add 1, that's 17. Plugged in a 0, we got 17. Y-intercept is 0, 17. As x approaches positive infinity, so as we go right, where are we headed? positive infinity. All right, it is now your turn. Now g of x here. Go ahead and pause the video, work it out, hit play when you're ready to check your work. All right, our parent function stops at the x. Once again, same one, 4 to the power of x. So we've got a point at 0, 1. We've got a point at 1, 4. It gets close to but does not touch the x-axis. Now, here's our transformation. It's going to go 3. Which way? It's with the x. Think opposite. We're going to go right. Right 3. Right 3. Asymptote. Right 3. So we didn't go up or down at all, so we don't need to redraw it. We do know that we're going to get close to the x-axis again. So get close to, do not touch the x-axis. What's our asymptote? Still the x-axis. The equation, horizontal line, y equals 0. The range, everything is above 0. Y-intercept, ooh, this one, we can see it's gonna touch somewhere in here. So it's gonna be very small. So this one we might benefit by using a calculator, substitute in a 0, 4 to the power of negative 3. If you do that on a calculator, you're going to get negative 0.015625. So very, just barely above. Where is our function increasing? It's always increasing. That's it for today. I'll see you next time.